Yeah, so basically today we are going to discuss about the next step of prepositional logic, and we can say that first order logic. Okay, so in the last class we are discussing about a different type logical connectivity. That means we are talking about negation, we are talking about conjunction, that means the intersection part, and the third one we are discussing about disjunctions, that is the intersection part, and fourth one is the implication, and the last one is a biconditional. Okay, that means five this logical connectivity we can discuss in the last class, that means the previous week, and today we are going to discuss about more, and we also discuss the truth table of these all the things. Okay, so that is very important because when we create a logic and when we try to create a facts on rule on the basis of this logical connectivity, we can take a help from that. Okay, so now today we are going to discuss about more advanced. So what is the meaning of logical equivalent? So these are the smallest things, so you should know. Sometimes they will ask you what is the logical equivalent. Okay, so logical equivalent, logical equivalent. So by the name we can understand logical equivalent. So you know the meaning of equivalent, that means equal. So when we can say that when two different truth tables are equal, then they will called logical equivalent. Okay, then is called logical equivalent. अगर सपोज इसका मतलब क्या हुआ, व्हाट इज द मीनिंग ऑफ दैट वन, कि व्हेन वी आर टू डिफरेंट ट्रुथ टेबल, नाउ सी सपोज वी कैन ड्रॉ p to q. This is the one truth table we can create in table 1 for this one. Okay, table 1. Similarly, this is equal to, suppose I am creating a negation of p union q. This is one, this is the one. Okay, so this is the, I am going to help of this one table 2. Now here table 2 is equal to table 1, then we can say that p implies q is equivalent. Now the triple sign is indicate that the equivalent, logical equivalent, is negation of p union q. So in place of this one, so wherever this is the place of this one, we can directly remove negation of p union q. So that is the logical equivalent. Okay, this is a very important thing because in examination they can give you property like a v union q, intersection r. Is it logical equivalent like this one? Sorry, is it logical equivalent like this one? Or not, this type of questions, not that is similar type of questions they will ask you what is the logical equivalent, we have to prove. Okay, so these are things for the logical equivalent. Okay, so I hope the words whatever I am writing in which size you are readable format, the word size is readable format or not, word size, is it okay for you, we are able to see and able to read? Yeah, anyone please reply. ये जो वर्ड्स है सॉरी, आपको रीडेबल फॉर्मेट में आप पढ़ पा रहे हो कि नहीं, ये ज्यादा छोटा हो गया ये? नो वन, सॉरी. Okay, now see, so little bit we are discussing about the properties. We already know all the things because these are very important for the logical based agent, knowledge based. That means KB. I am talking about KB agent. Okay, don't be forget कि I am discussing about DM. I am discussing about KB, that means knowledge based agent, and this knowledge based agent can follow propositional logic and first order logic. FOL, that means first order logic, not a faculty of law. Okay, first order logic, and we can say that a propositional logic. Propositional logic. Okay, both are same. Okay, now so properties of, I'm talking about the first property, as you know, commutative property. Sorry, commutative. So here we can write P union Q equal to like this one, Q union P. So this one is a pro, or we can say that this one is equal to this one. This is a commutative property. So as you know, so no need to discuss all the things. So already know lot of things you already know. So these things, whatever I'm teaching you, these already know in the class semester, fifth semester. I hope in DM. The second property is called as the associative. Associative. So what is the meaning of A union? Suppose I am writing like this one. So we can break like this one also. Okay. So these are the associative properties. Okay, so similar to the this one, we can apply on the intersection also, don't worry. So identity, that means P union true is equal to P, or you can say P intersection true is equal to also true. Okay, so don't be confused. P union true equal to P, P intersection true equal to true. Then fourth one we discuss about, already discussed, distributive. So this is a distributed, that means the combination of union and intersection. So suppose I am writing like this one, this one. So what I am going to write, P intersection Q union P intersection R. So this is the formula distributive. So don't be confused. Okay. So these things are there. And fifth one, we can say that. Fifth one, De Morgan's law. So not this is also applicable for the union intersection both. So this is the very important, we can use most of the time. De Morgan's law. So we can know the negation of P union Q, whole negation, intersection, negation Q. And suppose I'm going to apply negation of P intersection Q is equal to negation of P union, negation of Q. So this will be happened. Okay, this both will be happened. Okay, so these are the things we can apply. So De Morgan's law. And the last one, you can say that the double negation. Okay, little bit is stop. So the sixth one properties, we can say that because we are going to use, okay, so that's why it's very important. So double negation. So these things are very difficult to teach on the PPT. So double negation, that means we can like this one is equal to P. So these things, okay. So these are things are the logical propositional logic. Okay. So now, so what is the limitation? I'm talking about the limitation part. So these things, is it okay to you? Everyone, if you think that this is important for you, so you can note down, no problem. So now, so I'm talking about the limitation of prepositional logic. So what is the limitation? Now, can you see the formula and the property? We can apply only union and intersection, true or false. That means the boolean, zero or not. We'll not discuss about no one. We cannot discuss about all. Okay, it is very difficult to discuss all the things in the proposition logics. So we have to express this proposition logic in the form of the inference. That means now I can suppose that we can talking about the relationship, the symmetric relationship or transitive relationship. Suppose my father is someone and my brother is someone, that means my brother father and my father is same. So this way inference, we can create a logic, we can create a conclusion on the basis of reference. The lots of logical things are given on the basis of, we can find out the pattern and can derive the output, that is called the inference. Okay, so new terms we are going to learn about the inference, that means where we can discuss about all and someone and no one type activities. So that is very important for the inference. So where that is a limitation, where the propositional logic will be not work. Okay, so we can say that if someone asking you where propositional logic fail, so where propositional logic fell. So where when we are talking about all, when we are talking about some, when we are talking about none, so these things the propositional logic cannot be derived. Okay, and propositional logic are very less expressive power, so we cannot describe. Okay, so these things are very important. And statements cannot be derived in the form of the propositional, so we can say that statement cannot describe in terms of their properties. In terms of their properties. So what is the properties? That means I'm talking about the commutative De Morgan's law, all the things. Okay, so these are the. So apart from these two, maybe possible the proposition logic may be false apart from these two conditions, but these two conditions is the major conditions. These two conditions very major. So this are the mandatory. Okay, maybe something is possible, so we cannot limit that one, but this one is a very important. All, some and non. Suppose I want to describe the all set, so it is very difficult to describe in propositional logic. It is very difficult to describe some, none, all the things. Okay, so these things can be conclusion on the basis of the evidence, on the basis of the fact is called as a inference. Okay, so now this drawbacks we can remove some, all the things with the reference of inference. Okay, so we can use the inference. So that's it is also. So conclusion, we can write that conclusion from evidence and fact is termed as inference. Okay, this is termed as a inference. This is term as an inference, and that is a very important. Okay, so this term is very important, inference. Okay, this term is very important, inference. So we can discuss about inference rule. Okay, inference rules. So before that, inference rule. So in inference rule, we can including some terminologies. Okay, in inference rule, we are going to include some terminology. Inference rule. So we are discussing about first one terminology is now is implication. First one, implication. So implication, what is the meaning of implication? That means I'm talking about the Boolean implication. So now it's cover the concept of propositional logic also. So now it's clear, no problem. So second point is called as a converse. Converse. Okay, so converse. So what is the converse? That is a opposite of implication. Now whatever the left hand side of implication is comes inside the right hand side of converse, and left hand side goes to the right hand side, that is converse. Okay, so don't be confused about converse, implication. Then third point is called as a contrapositive. Contrapositive. So contrapositive is termed as that is the negation of converse. That is a negation of converse is called the contrapositive. Okay. Suppose if I want to represent any statements in terms of converse, so just suppose I am writing uh, it is raining. Raining, then today, Monday. Okay, so don't we go for the meanings and all the things. Just it is raining. Suppose this is my P statement. Today is Monday. This is the Q. That means P implies Q. Okay, wait. Wait. No power. What? Okay. So actually, my battery is down and in the classroom, no power in the socket. So now see up to this one. Huh. Now see, we left out. How much battery I have? 20%. Okay, no problem. Now see, this is the P and this is the Q. So that is the implication. Suppose I want to use the conversion. So what we have to do? Today is Monday, then it is raining. Now Q, Q. Suppose I'm writing contrapositive. So today is not Monday, then today is not raining. That is this one. Okay, that is the this one. This way we have to implement. And the fourth one of the best, we can say that inverse. So inverse is a opposite of, not opposite. That means we can say that just a implication, similar to the implication, and we can apply like this one. That means whatever the implication is given, just you have to put the negation. Okay. So now converge and contrapositive both are interrelated. Okay. And implications and inverse are both are implications. Okay. Both having the same but negation here, and both converse is the opposite of implication Q and P and negation. So these are the inference rule where we can use the terminology implication, converse, contrapositive, and inverse. So they will ask you, okay, is it possible to convert this statement in converse or contrapositive inverse? Or you have to write the converse statement of the given statements, all the things. And we can also know the truth table of this one. Suppose you know this one truth table. Suppose you know this one truth table. So the very suppose you know this one truth table. So very easy to write a truth table, all of the things. Okay. So now I'm discussing about here in the previous one, what we have discussed. This one is the rule for the propositional logic. This is a property of propositional logic. So now similar to the, we are discussing about inference rule. Okay. So these are very useful for the KB. Okay. So most of the time we are going to use KB. KB agent. Here is not a 007. These are KB, knowledge based agent. Okay. No power. Wait, maybe. Yeah, working. Chala. No tension. Now see, I'm talking about the inference rule. So these are very important. Okay. That means types. The first one is called modus ponens. Okay. The first one is called modus. So already discussed in, we already study in the discrete mathematics. Ponens. Okay. Modus ponens. So what is meaning of that? This is a very important. If we can say that this is the rule of inference. Okay. So this is a implication that, so we can say that if P and P implication Q is true, then Q is true. That means if P to Q is the true and P is a true, then this is also Q is true. So that is the result. This one is the result. Okay. So this one is a result. Don't be confused. Q is a result. So for this purpose, this should be true. This whole statement should be true. And this is also true. then this statement is true. So now understand, P and P implication true. So now see, so what is the truth table? So I'm going to write 0, 0, 1, 1, 0, 1, 0, 1. So this one is the P, this one is the Q. Now see. So in which scenario P implication true? So this is true. So this is true. This is false. This is false, and this is true. So that means this is true, and what will the P's are true? So no. So this one we discarded. Now P and true, and P's are true. So this will be discarded. Now this will be the only one statement. That means this will be the true, this will be true, then it's true, then this true, and this will be true. So this way we have to find out the result. Okay, so that is why we call the inference rule, modus ponens. If P and P implication Q is true, then we can say that Q is a true. Suppose this P is a false, this is a false, and this is a true, so we cannot say this is the true, this is the false. ये हम नहीं बोल सकते हैं. Okay, so don't be confused this type of questions. Okay, these are the statement type questions. Even in the form of A B C D Q R S T, कुछ भी पूछा जा सकता है आपसे. सो अगर आपको रूल्स याद हैं तो आप बना सकते हो, नहीं तो नहीं बना सकते. दैट इज द फर्स्ट रूल, मॉडस फोनेम्स. द सेकेंड रूल इज कॉल्ड सेम मॉडर्न्स टॉलेंस. Okay, so inside that, if what we have to do, so if P implying Q is true and negation of Q is true, then we can implication that this one P implication will be also true. तो तब जाके आप बोलोगे कि ये भी ट्रू हो सकता है. ओके, सो दिस वन, इफ P implication is true, this whole table is true, and this is also true, then this will be the true. Okay, then negation of P will be true on the base depend upon P implication Q, and like this one. So how to write P implication Q like this one? We can say that this will be the true. That means here true, that means we can get opposite of P. Okay, so that we have to get, that is a possibility, we can get a opposite of P. Okay, so this way. So that is the meaning of that one. Okay, don't be confused. Up to this much, is it clear or not? या देखिए, ये आपका पूरा थियोरेटिकल पार्ट है और लॉजिकल पार्ट है. ये आपको पहले प्रॉपर्टीज पता होने चाहिए, देन यू आर एबल टू डू अ क्वेश्चंस. अगर आप प्रॉपर्टीज पता नहीं होंगी, टर्मिनोलॉजीज पता नहीं होंगी, तो आप क्वेश्चंस नहीं कर पाइएगा. सो माय फर्स्ट टास्क टू you can become a familiar with these terms, then it's very easy to write the questions, very easy to write the answer of the question. Okay, क्योंकि क्वेश्चंस में दम नहीं होते. अगर आपको प्रॉपर्टी याद है, अगर आपको टर्मिनोलॉजीज पता है, तो then it's very easy to handle, apart from the other part of the AI. Is it clear or not? Yeah, please anyone reply. Only Harsh, Vivek, okay, the CR all the time. And next, rest are what are doing? Nothing. Okay, no problem. Now see, so these are very important, and those who are writing are thinking about writing a gate, so that is very important. Okay, so most of the time when where we can apply, suppose अगर आप बात करें ना, जैसे रियल लाइफ की हम बात करते हैं, तो नेटफ्लिक्स, यूट्यूब, सारे लोग इसी पे वर्क कर रहे हैं. सब लोग लॉजिकल के भी नॉलेज बेस्ड एजेंट पे ही काम कर रहे हैं. ओके, दे वर्क ऑन द नॉलेज बेस्ड, एंड दे कैन यूज लाइक ऑल द थिंग्स ऑफ ट्रू एंड फॉल्स, दिस प्रॉपर्टीज, ऑल प्रॉपर्टीज यूज कर रहे हैं, फर्स्ट ऑर्डर लॉजिक का और प्रोपोजिशनल लॉजिक का. ओके, तो दैट इज द फ्यूचर, सो वी कैन टेक अ इंटरेस्ट. चलो, नेक्स्ट वन, hypothetical syllogisms. Sorry, fourth one, whatever. Hypothetical Silogenes, silogenes. Okay, so what is that? It rules state that if P to Q R is true, that means this is the result. If P to R is true, only whenever that means whenever P to Q is true and Q to R is true, then we can say that this is true. Okay, so ये हमारा सिमेट्रिक प्रॉपर्टीज है, ट्रांजिटिव प्रॉपर्टी. अगर P से Q ट्रू होता है और Q से R भी ट्रू होता है एंड तो आप डायरेक्ट लिख सकते हो P से R हमेशा ट्रू ही होगा. So that is the meaning. So if P to R is true, whenever P to Q is true and Q to R is true. So that is the slope. Okay. So we can create a proof table also, no problem. So disjunctive rules क्या होता है? Disjunctions I'm talking about. So we can consider disjunctive syllogism. Okay. So what is this one? This is the intersection part. So we can say that if P union Q is true, that means whatever is true and negation of P is true, then we can say that Q is true. So we can write agar P union Q is true and negation of P is true, so what we have to derive from this one? So Q is true. That means Q is true. So that is the answer. Okay. So someone told that if today is a Monday, Tuesday or everything and today is not a Sunday, then we can derive that today is a Monday. Okay, this is the example. Okay, someone now see how we can use. Suppose my name is MK or PK. Suppose this is the MK and PK because I'm here using a disjunction, so I can use or MK and PK. And someone told my name is not MK. तो इसका मतलब क्या हुआ? My name is PK. That means Q. Is it clear? So this one is the, now see, this one is the P, this one is the Q, this one is the negation of P, and this one is the Q. And this one is the true, this is the also true, then this one. Is it clear? Example? भाई समझ में आ रहा है हम लोग कैसे यूज करेंगे सेंटेंस में? At least Vivek, Hers and Sagar, those who are replied, please respond. चलिए अच्छी बात है फिर तो. So this one. So next one is called the addition. So addition is very easy. So that is if P is a true, only one condition we can follow. First I have to write the name. Oh, tired. Addition. If P is true, then we can say that then P union Q is true. So as you know, this is a very easy. We can derive like this one. P union Q is a true. Okay, this one is true. Very easy. अगर ये ट्रू है तो इधर क्या मतलब है? ट्रू है फॉल्स ऐसे में कोई फर्क नहीं पड़ता, P ट्रू ही होगा. So that is the way. So you already know. Sixth one, simplification. So sixth one is a simplification. So now if inside that if P intersection Q is true, अगर ये true है, so then we have to implement Q or P will also be true. P will also true. So that is a very simple. So अगर आपको ये पता है कि अगर ये हमेशा true result देगा, तो इसके लिए आपके पास P को true होना पड़ेगा और we can say that क्यू को ट्रू होना पड़ेगा। तो ये तो सिंपल से आपको पता है कि दोनों को इंटरसेक्शन में ट्रू होने के लिए इसको भी ट्रू होना पड़ेगा, उसको भी ट्रू होना पड़ेगा। ओके, देन थर्ड वन, seventh one you can say the resolution. In resolution, what we have to follow, if P union Q and negation of P intersection Q, sorry, R is true, then we have to implement Q union R will also be true. Will also be true. That means अगर P union Q true है and negation of P intersection R भी true है, तो ये भी हमारा true ही होगा. Okay, so don't be confused all the things. The proof tables we have to create. Okay, so these things are there for the inference rule. So in the inference rule, Wumpus. So in previous class in KB agent, what we have to discuss? Wumpus. Wumpus game. WUMPUS. Wumpus. So that we have to play this game. So on the basis of inference, we can play this game, Wumpus game. Okay, where Wumpus is present, we have to kill the Wumpus, or we have to take a gold or return our original place. So this is the Wumpus games we can play in the field with the help of inference. Okay, some conditions given, then it is follow. Okay, so these things we are discussed today. So rule or inference, propositional logic. Then we can, the next class we are going to discuss about more advanced, like a first order logic, then knowledge in engineering on first order logic, all the things, unification in first order, resolution, then forward and backward chaining, and then inductive and deductive approach in propositional logic. So that is the whole syllabus of your KB, knowledge based agent, and one thing also discuss, conceptual graph. So the conceptual graph is very easy, so don't be confused. Also, don't be worried. So all the things. Okay. So for this week, we try to cover this unit. That means the unit number 5. Wait. Where is your syllabus? Okay, don't worry. I will take care of it. So for today, anyone doubt up to this one, inference rule? No doubt. So if you understand the inference rule, so then very easy to play Wumpus game. So first you can try how to find out the Wumpus and how to kill the Wumpus and how can escape from the Wumpus. So my advice is go through it and play this game. Just follow the conditions. We have to define the fact and rules and then play. Okay, so you can play also this game. So no doubt. So after this, what we have to do? Then after this one, we can going to start from the next week machine learning. Okay, the machine learning part that is called seventh unit, I think. No, sixth or seventh. Okay, this may be your seventh, sixth unit. And then seventh and eighth unit is a prologue. So prologue is very easy. We already cover in the lab also. So don't worry. So two portion is more than enough to complete this one. So in September of last, maybe your syllabus is completed because 9th of October is your last date. So up to ninth we can complete all the things. Okay, so don't worry. Is it clear? Okay, Vivek, you can send me the attendance.